Hi, this is Captain Jesse Edwards. Going to make a few comments on a vessel that Cheeki Rafiki. It's a first Beneteau 40.7. The subject come to my attention earlier this week. It had a catastrophic keel attachment failure. Uh, some of the remarks that I saw online, uh, they kind of touched on a lot of subjects, but it's such a broad subject that there are a few things I would like to add to their attention. Hopefully someday it might save somebody's life. In this case, 4 men were lost, and I think there's a great area of gray here. The people that did the examinations, I think, may have missed a few of the things that could have happened. Like I say, these are just my opinions, and you might want to think about this. In the groundings that they reported, 2 heavy groundings. In the repairs that were done after the groundings, was the keel removed? It's a bolt-on fin keel. Was the keel removed for repairs, or was it simply jacked, as they call it? They drive wedges into between the keel and the hull, and they put a bunch of goop in there, fiberglass resin, epoxy resin, whatever the case may be, and a lot of times materials like 5200, I'm sorry. Uh, was the help the yard workers? Were they qualified to do this kind of work? Was the work supervised? Was it inspected before, during, and after the repairs? Or a lot of times, unfortunately, as you're paying, let's say, 75 or $100 an hour for repairs on your boat, bottom, obviously not bottom painting, but a lot of times these repairs are left up to the yard workers, not only to do the work uninspected, but to make decisions on what they would think would be the proper repair for some of these situations. We really need to look at yacht surveyors, their experience. We need to look at the yard that you're going to. Are they experienced with just small repairs, gel coat repairs, paint jobs, that kind of stuff? Or are they really intent on fixing boats that are damaged like this and keeping the people safe on these boats? Some of these boats are not qualified to go offshore. This type of boat, Beneteau, they've had problems with other boats from what the comments say online. But did anybody really do any hard inspection? I'm sure their intentions were good, but myself I consider myself a glass expert in repair. I've repaired multiple damaged boats over the years with severe conditions of damage, where what you see is not always what you get. Something in this situation where the keel fell off the boat, pulled through the hull lamination. Uh, were the repairs just made simply inside the boat, caulking on the outside, repairs on the inside? Unfortunately, a lot of times uh, when they retighten a keel, whose specifications did they tighten those keel bolts? Were the keel bolts loosened and retightened? Were the keel bolts drilled down the center to see if there was any corrosive action on the stainless steel bolts? My big concern was the electrolysis. We fight with zinc anodes on the shafts and props and rudders and that kind of stuff. They don't really, they take a lot of the electrolysis that could attack your propeller, that do attack your stainless steel at locations where there's saltwater intrusion and oxygen, stuff like that. Stainless steel, unfortunately, is subject to corrosive rot. It almost looks like a bad cavity in one's tooth. This kind of corrosion is very hard to detect. My one concern here is lightning strikes. A lot of boats have lightning strikes that are never detected. They're never addressed. You first see this in chain plates or backstay, like antenna insulators, that kind of stuff. And you'll see it in turnbuckles, cracks and fractures and this kind of stuff. But when it comes down to a boat that has this kind of catastrophic failure, we need to look at, okay, the keel was obviously broken away from the hull for many, many reasons. Were the repairs done right? Did we consider drilling the keel bolts? Did we pull any of the keel bolts out of the keel for inspection, which is not easily done, obviously. Drilling down the center, sometimes that will show it. Sometimes you have to drill multiple holes in different, multiple holes in the same keel bolt, or several keel bolts to say, okay, yes, the forward keel bolts did show signs of corrosion and electrolysis attacks. If lightning struck these same areas, and you have to figure all of the grounding systems, your radio, your engine grounding system, your 110 volt, your battery chargers, all of these systems most likely are grounded to these very keel bolts that are supposed to hold the keel on. Okay, if any of this happens, the area of fracture that is caused from lightning strikes or corrosion or groundings can look a lot alike. Unfortunately, without core samples. Now, we don't have the keel in this particular boat. The photograph that I looked at is quite familiar to me, very common. Unfortunately, it's common. When a keel does break away from a hull, usually that means that the fracture of the fiberglass or laminate schedule has been destroyed from one of these factors. Let's say when it was grounded, it fractured an area that appeared to be about a half an inch in diameter, larger than the keel bolt. False security. If you examine that keel bolt, if there's glass fractured half an inch away from it, a 6-inch in diameter, quarter-inch thick washer is not going to fix this situation. Someone who does fiberglass work would know to take a core sample, not just next to the keel bolt, an inch away, 2 inches away, a foot away if necessary. These kind of damages, especially if they're lightning, and I'm just saying as an example because nowhere in any of the comments did I see anything about lightning strikes. The groundings themselves, yes, that can cause a fracture in the glass, and it can cause big areas, 6 inches, 12 inches, 14 inches. These repairs need to be done from the inside and the out, which requires the keel to be removed, unfortunately. A lot of these boats are built so the keel can come off for shipping. Okay, when it's reattached, are there problems? Look at it before you send it to Europe and try to sail it back. Okay, if it's sent the other way, let's not try to go to England with a keel that's been removed and replaced without severe inspection of the keel bolt holes that are placed through the hull laminate schedule, often through the entire laminate of the hull, into the bilge area where there's salt water, there's bonding straps, there's corrosion, there's a lot of things. There's electric bilge pumps and drains that come from refrigerators and air conditioners, and sometimes gray water ends up in the bilge area. All of these factors are considered dropping coins, pennies in the bilge. Very dangerous on aluminum boats, but another subject. All of these are factors in the damage around the keel bolts. Like I say, putting a large washer on it will cover up the problem for a while. When 4 men lose their lives because of shoddy workmanship, not dishonorable, but people that were doing repairs that may not have been qualified, or even if they were qualified, were they inspected after the repairs were made by a qualified fiberglass expert, a structural engineer, or even the designer itself? That designer would rather you call him and interrupt his Sunday dinner than be named in a lawsuit later. This has happened before. So one of the examples is Michael Plant. He lost his life. Now his boat was a one-off, one design racing boat. A lot of things happen. Some surmise that he may have struck a land and sea container, steel or aluminum box that you see on tractor trailers going up and down the road. They end up on cargo ships going overseas. A lot of times they'll lose hundreds of these things off these ships a year. You strike one that's slightly submerged, you have problems. Some of the things I went over, the core damage and that kind of stuff, just structure to the damage of the laminate, this can be around one keel bolt, could be as big as a foot in diameter. You don't know until you take the keel out of the way or out of the back, out of the position, and actually drill and core sample, just like taking a core sample in your dirt in your backyard. Will it perk? Is it strong enough, to hold the systems that you're going to apply to it? Let me get to my notes here just briefly. With movement in a keel that has been, it's been grounded several times, obviously. Maybe it's a charter boat, whatever the case may be. Intrusion to the keel bolts, any of the keel bolts, whether it be from a crack from the outside or inside, like I mentioned earlier, The corrosive action against these bolts cannot be seen unless the keel bolts are exposed and physically examined. Sometimes my wife has a niece. She works for a stainless steel company that manufactures U.S. stainless steel. She is a metallurgist. She can take examples of the keel bolts themselves, examine them, and you can send your keel bolts or an example of the keel bolts to places like this. They'll examine it and tell you whether it's caused from corrosion, lightning, overstressed. A lot of the keels that I see nowadays bolted onto the bottom of the boats have a very small, in perspective, a very small landing onto the hull. In other words, where the keel actually touches the bottom of the hull, where it's attached, where you make the seal. A keel that's, say, 6 feet down in the water from the bottom of the hull with, on Michael Plant's boat, I believe it was like a 15,000 pounds of lead at the bottom of it. If the keel bolts are somewhat limited in their spread to the attachment to the hull, in other words, the keel at that point is very narrow, you have to have, there's a lot of critical measurements and stress analysis that have to be taken in consideration that will this set of keel bolts that are separated by no more than, say, 4 or 6 inches, maybe a foot difference, will it support a 15,000 pound keel 8 feet below the surface and take a strike without severely damaging the keel attachment point? In other words, there's not a lot of flare to the hull. Most of these hulls are flat in that area. The keel attaches. There's no flange to go up inside of the boat. There's not a lot of radius to the keels. They go straight up. And I had a teacher years ago, my dad, and he had a saying, if you cannot access something with your elbow on a boat, it's a poor design. Well, in this factor, a flare into the bottom of the hull might cause the boat's performance to slow down a bit. Would you notice it if you were racing every day? Maybe. Like on a Star or something that's a keel boat that is made to go fast in, 8 feet of water or 10 feet of water, whatever. The chances of that boat grounding and causing a lot of damage are minimal. And you take something that's 40 feet long, weighs, say, 20 tons or less, strikes an object, whether it be the bottom of something else. When it strikes a sharp angle, which you'll see on a lot of boats in a boatyard, go through the boatyard and look. You'll see that real sharp angle, 90 degrees a lot of times, where the keel attaches to the hull. This is a cause for concern in my mind. Stainless steel is another concern. Stainless steel, if you bend the stainless steel, no matter how big the bolt is, if it's 1/4 inch, you can take a crescent wrench and wiggle it a couple of times, 3 or 4 times, side to side, not very far, not even a deflection of 20 degrees each way. And on the 3rd or 4th bend, it will break off. It will shear completely off. And that's done in manufacturing a lot. When the bolt's too long, you wiggle it a little bit, shears off, you grind the face of it, you're good. You retorque the nut. The other concern is if the keel was not removed. A lot of times I see this. The keel bolts, they'll lift them up, replace the washers, larger washers, and bolt the keel bolt back on. In other words, tighten it back into place. Whose specifications are they using for this retorque method? If they didn't do the glass work, they didn't do their homework. Unfortunately, I see guys they'll walk up to a boat and have a piece of pipe, 4 or 5 foot long piece of pipe, and they'll stick it onto a 3/4 inch drive ratchet or breaker bar to a socket and tighten these bolts just as tight as they possibly can, sometimes having more than one person push on this pipe. Specific dynamics are placed on these bolts. These bolts are meant to hold 8,000 pounds, 6 feet below the water, under certain circumstances. Over tightening these bolts, especially on used boats that have been in the water, in service, may have been damaged several times, it's a factor that it's inconceivable how anyone could actually make a qualified guess on how tight these should be after the damages that have been caused. If they're corroded, you're going to snap one off. Bad news. Were the repairs on this boat, did they add more keel bolts? I don't believe so. Did they add large washers? Yes. You can see that in the photographs quite clearly. And you can see a stainless steel jig or a strongback that was made and placed in position. These are all simple repairs done to a much larger problem. Cost prohibitive. There's the big key. Will your insurance company, or will you pay out of your pocket to pay to have this done right? Scheduling. A lot of times on a schedule. The boat's scheduled to be in charter in the Bahamas on June 1st. Will the repairs be done right, or will it be a patch over? Unfortunately, the patch over wins. Who loses? The 4 men that took this boat not knowing what was under them. Did it have fancy interior and fluffy cushions and a fancy stove? I'm sure it did. Did anybody inspect the boat before it left? I'm sure somebody looked in the bills and said, oh yeah, they reinforced it, they did this, they did that. That's fine. Somewhere the liability is going to rely on and go back to whoever made these repairs. Okay? And the initial design, unfortunately in Michael Plant's situation, he's a racer, he knows, he's in a NASCAR of the ocean. He knows his risk. He knows the boat was built to extremes. And in most cases, cost was not a problem in these race boats. Just like NASCAR, cost is not a problem. Fix the problem, fix it right, get out and race. Or in this case, put that boat back in charter, get her where she needs to be, put her back in service, and make money. If the cost of the repairs outweighs the value of the boat, you're in a bad situation. Some of the other things I wanted to touch on in my notes here, during the building stage and construction of a lot of these boats, I've seen it myself personally in many shops where time restraints such as we have to build 4 boats this month with a crew of 4. Okay, powerboat, okay, we're good. 30-foot sailboat, okay, we're good. Do we have time restraints? Yes. Weather restraints, help doesn't show up. You get somebody that's, not really concerned. They're there because they need a job. If there's not a qualified individual supervising, on the floor foreman that's watching the work, a lot of times, and unfortunately this is a lot of times, they will, as they're using a wet out gun, or they call it chopper gun, a lot of times, if they're using a wet out gun, they'll turn the hardener, which is a catalyst for the, in a polyester boat, it would be methyl ethyl ketone organic peroxide, which is the catalyst that makes the resin get hard. It's mixed at 1.5% by volume. If they're in a hurry, they want to get out of the shop by 4 o'clock, they'll up that to 2.5%, 3%. If they're in a real hurry, like I've seen at a very well-known boat building company, Wellcraft, unfortunately, they had a run of bad luck. They built several boats that ended up in lawsuits. They were settled. The problem with the boats were the resin and the laminate, hand laminate. Okay, the word hand laminate, they use chop and they use a chopper gun a lot of times to just put the chop, which is the woven, not the woven woven, but the bilateral strung chop fibers of glass. They'll run that through a chopper gun, which is a top the wet out gun, which sprays the resin and the hardener at the same time, and it infuses the resin into the laminate, and then they bring the woven and different laminate schedules. If this schedule is done in, say, a 3 to 4% ratio on an 85-degree day, we have problems. 2-3 layers, you're safe. Maybe you're safe. It's negotiable. Temperature, atmospheric conditions play a big role in this. Ventilation in the shop has a big relationship to how this laminate cures. If the laminate schedule is laid up at one time and overheated, you have a design engineer that said, okay, we need 12 laminates in this keel, and that's 12 laminates of woven or biaxial cloth in this keel section. whether it's over laminating or not, which would be 24 laminates. If this is what's called by the designer, he wants that done in a progressive, controlled atmosphere and schedule. He does not want this boat to be shot hot. If you go through the boat yards, that will be a common term, shot hot. The workers put in too much hardener, the resin overheated, causing not only air bubbles in the lamination, but separation of the laminate schedule and fractures where the resin does not attach to the glass fibers. And in the chop, that's a problem. You see that in blisters on the outside of the boat. That's a whole different subject. But when a laminate is laid up so hot that it turns brown in production, and you don't want to see this on your boat. Believe me, if you go in the shop and you're watching these guys build your boat, and they're shooting this stuff, and the resin is hot enough to turn brown, you don't want that boat. In this powerboat company situation, several of them got through, which is, they built a lot of boats. Thousands and thousands of people have enjoyed their boats for many, many years. 25, 30 years they've enjoyed well-craft boats. The situation that they ran into was whether it was poor supervision. Let's just put that as a broad spectrum of what we're looking at here. In their situation, some of these boats were shot hot. Unfortunately, they cracked. Lives were lost. People lost their weekends where these boats fractured, water intruded the hull, people were left swimming, survived, but swimming, maybe not too far from the trailer, but unfortunately a boat is meant to float, not to sink. This situation happens in all boat building. Sorry guys, it happens on the floor. The designers, the builders in the office, they all want this to come out right. The foreman wants it to come out right. Everybody's making money. We're having a good time. This is a pleasure craft. And when restraints, like time restraints, I'll get back to that subject, because so often a boat is built for the boat show, the Annapolis Boat Show, the Miami Boat Show, the LA, the London Boat Show, whatever the case may be. A lot of times, okay, it takes 3 weeks to build a 30-foot sailboat. They come out to the shop foreman and say, well, we need this particular boat in 2 weeks. We're not going to hire any more help, but we need this boat in 2 weeks, so plan on overtime. You can expect, not just sailboats, I'm saying, you can expect that there's going to be some corners cut. And 99% of the time, unfortunately, it's in the laminate schedule. Easiest to hide, easiest to cover up. The hull, the most important part of the whole structure, has been compromised because of a boat show schedule, or an owner is going to put it in charter, or the owner has a vacation coming up, and of course he wants that boat to be ready. His family's ready, the food's ready, cold beer, whatever the situation may be, hot boats do occur. Keep your eye out for it. If you have any doubts whatsoever, this can be covered up with gel coats. If you see in the bilge, if you see a crack in the gel coat in your bilge, have a qualified inspector drill a core sample, not a drill hole, actual core sample, which means you take a hole saw, drill it, pop it loose, and pull it out and actually look at the laminate schedule. You don't need a magnifying glass. It will tell you right away. Does it look like cotton with no resin? There's your problem. The resin has separated from being shot hot. This could take days to occur, but normally it happens the same day. They'll see the laminate getting hot. They'll throw a couple of layers on it. The next day, cover it up with gel coat. Not all companies do that, but it's something to be aware of. Okay, back to my notes here. Calendar events, like I say, that's really important. Polyester resin, I talked about the unfortunate mishap that I am personally connected with the powerboat company. This happens with sailboats. Okay, suddenly we have the deck is ready, the hardware is on the deck, the hull is being hot shot to meet the joining schedule. In other words, the guys that are building the decks, their job is done. It's time to attach the deck to the hull. This is where you need, if you're going to buy a new boat, go watch it being built. Have somebody go film the boat building. have it built under Lloyd's registry. There's a lot of boat inspectors and boat surveyors that will be more than happy to protect your investment and your lives. And keep an eye out on used boats. A lot of times there have been repairs made and they will never fail if the boat is used properly. But we can't head across the Atlantic in a boat that we've not thoroughly inspected and investigated not only the building and the construction, the design, but also the repairs made to it and by who. This is Captain Jesse Edwards. Keep an eye out. Be safe. Thank you.